All right, welcome back to Learning YouTube, or Learning on YouTube with Wilkie. Today we're going to talk about torque. We will define and calculate torque. Okay. If we go back here and you see right here this weird looking T, it's like half of a pi symbol. That's the Greek letter for torque, tau, torque. Okay, T-O-R-Q-U-E. All right, so what is torque? Here's a definition for torque. Torque is defined as a force applied to a lever arm that rotates about a pivot point. Okay, so anything that pivots, all right, when you apply a force some distance from the pivot point, that's going to be a torque. You're applying a torque. Okay, so here's the lever arm. If we talk about this as the lever arm and we apply, and here's your pivot point right here, because clearly if we push down on this, it's going to pivot about that fulcrum, that point right there, and then we apply a force here, all right, then that whole lever arm is going to turn about that point, the pivot point right there. And you also need to know something very specific about this. You need to know the radius from the pivot point to the point where the force is applied. Okay, that's very important in torque. All right. The second thing you need to know about this force is that we're only talking about forces that are perpendicular to the lever arm. Okay, we're not talking about forces applied this direction. Just forces applied perpendicular, meaning it makes a right angle right here with the lever arm, the direction of the force. Okay, so here's the equation. Tau equals force times the radius. Okay, the radius from the pivot point to the point where the force is applied. So it's the magnitude of this force times the distance from the point where that force is applied to the point where the force, where the lever arm will pivot. All right, let's look specifically at the units for torque, because we talk about units for force being newtons. We talk about units for distance. Usually we use meters, sometimes kilometers. We talk about velocity being meters per second and acceleration being meters per second squared. So units is also very important. All right, so if we look at the equation, tau equals force times r, okay, torque equals force times the radius, then we're going to be looking at here tau is equal to a force, which is a newton, times a radius in meters. Okay, when you multiply those things, you get simply Newton times meters, or Newton meters. This is going to be the units for torque. So let's use a door for an example. You apply a force of 36 newtons to a door handle that is 4 meters from the door hinge. What is the magnitude of the torque you apply to the door? Okay, we want to know the magnitude of the torque. Remember, magnitude is just another way of saying what's the number. How much torque did we apply? All right, so here's our door. This is going to be the hinge right here on the end. This is going to be the handle. It's a bit crude, but it works. All right, and we apply a 36 Newton force here. 4 meters. The force is applied 4 meters from the pivot point right here. Here's your pivot point, and the hinge is 4 meters on the other end of the door. All right, so if we're following the PSR, we're writing what we know, because here's the picture, the free body diagram. We know force equals 36 newtons. The radius, r, is 4 meters. Here's our formula. Tau equals force times radius. Okay, torque equals force times radius. We're going to substitute what we know in. We know the force is 36 newtons. We know the radius is 4 meters. We're going to multiply those things and get torque is equal to 144 Newton meters. All right, so the amount of torque you applied to that door is 144 Newton meters. Did we answer the question? What is the magnitude of the torque applied to the door? Yes, we did. Torque equals 144 Newton meters. Now, something interesting you learned from this, if we look at torque equals force times radius, if you talk about this force here moving closer to the hinge of the door, you know that when you you open a door, when you push closer and closer to the hinge, it gets more and more difficult. More and more difficult to open. Okay, you have to apply more force because your torque is actually decreasing. Because if R here decreases, then the torque will decrease, and it takes more force to apply a significant amount of torque. Okay, so the smaller the radius from the pivot point, the harder you have to push on that object. Okay, that's why long lever arms are more effective. One more example. A force of 23 newtons is applied to a wrench that is 0.34 meters long. What is the torque applied by the wrench? Assume that the force acts perpendicular to the length of the wrench. Okay, so let's draw a picture. Here's my wrench. Doesn't look like a wrench, but it'll work for picture's sake. Okay, here's the force, 23 newtons, applied at the end of that wrench. Okay, notice the force is perpendicular, meaning it makes a right angle to the lever arm or the wrench. Okay, we're making a right angle here. And the distance from the pivot point, we're assuming the pivot point is at the end of the wrench, is 0.34 meters to the force to the pivot point, force to pivot point. Okay, so what we know, force equals 23 newtons. We know that the radius is 0.34 meters. So here's the work. Torque equals force times R. There's the formula. Substitute in what you know. Torque equals 23 newtons times 0.34 meters. So the torque you're applying to that wrench is 7.82 Newton meters. Okay? All right. Enjoy the practice.